In this video, I'm going to attempt to figure out what happens when you have two roofs with the same pitch, but instead of the walls meeting in plan view at the normal 90-degree angle, if the angle is bigger than 90 degrees. So I wanted to see what happens, especially to the valley rafter. Special thanks to Red, Kevin, Tim, and Arlo for tolerating this nonsense on the job site and for inspiring this video. Take off the plywood for a second. There's a few things to notice. One is that the fascia is pretty normal, except for that the cut where it intersects there is not going to be two 45-degree angle cuts. It's going to be whatever this angle is, divided by 2. The common rafters are pretty normal. Nothing special going on with those. The valley rafter is a little different, and what Tim calls the lizard's tongue, that isn't going to be quite the way it's normally done. So again, normally you'd just be able to do 45-degree angle cuts. 2 45s equals 90, but in this case you have to take whatever this angle is here and divide that by 2 to get that cut. And of course, another thing you'll notice is that normally the valley is a nice 45-degree angle in the plan view, and in this case it's not. So the first thing to do is to make perpendicular lines snapped out on a slab on your job site. Check to make sure they're perpendicular with a 3, 4, 5 triangle. So now that I have the two perpendicular lines here, those are a 90-degree angle. And then I want to figure out whatever the angle that's bigger than 90 degrees is. In my case, it's going to be 110 degrees. The way I'm imagining someone would figure that out on the job site, this is my little placeholder for a speed square. You might have to prop that up a little bit with a slim piece of wood to get it to be in the right spot. But then you can make a mark and you can trace a string through and you can snap the line of whatever the angle you want is. In my case, it's 110 degrees. Then I take two lines. I take this horizontal line and I take my line that I just defined, the 110-degree line right there. And because the two roofs have the same pitch, I'm going to do offsets of the same amount. It could be 6 inches or 10 inches or whatever. In my case, I'm just going to do 1 foot offsets parallel. So I take this line and offset parallel 1 foot and just keep doing that a few times. And then with this line again, I just take that and do an offset parallel at 1 foot. And then I connect the dots here. I draw a little line that crosses right through like that. And what that line is going to do is it's going to help me so that I have this and this as my wall plates, and that right there will be the valley. So I've set it up here, so these are those lines that I had. This line and this line here define my wall plates. So I've got my wall plates snapped out right there, and I want this line to intersect right there where the wall plates meet. And in my case, I'm going to do a 30-inch overhang so that when I offset parallel off of my wall plate from here to here, that's 30 inches. And I do the same thing off this one. I offset parallel, and my fascia from here to here is 30 inches. So that's all standard, but there's another important dimension here, and that is where the fascias meet. I measure back until I have the distance to where the walls meet. And so that's 3 foot and 5/8, or 36 and 5/8. So I would again want to have perpendicular lines. So I've got vertical, horizontal there. I want all my top plates in this case to be landing right on that line. So I've prepared my valley top plates off to the side. I've got the top plate here landing at that line. And I know a few things. I know that the distance off, if I offset off that top plate, that's going to be 30 inches. So I know that. I also know that if I take my rise and my run to the back end of the top plate here, that from here to here is going to be 1 foot, and in the case of my roof, from here to here is going to be 6 inches because it's a 6 and 12 roof. And so I connect the dots there, snap the line through, and where this and this intersect ends up being important. So if I take that line and then I offset 5.5, that'll give me my rafter, and then I offset another 5/8, and that will give me my plywood. There's one other important line that I want to get. Now that I have this line that I'm going to transfer for the nosing of my plywood, so I've got that horizontal line, it's parallel to the top plate line. The top plate line will be parallel to this other line, and so I draw a plumb line up from the outside edge of the top plate until I hit the plywood right here. And where this and this intersect, that's where that other horizontal line goes. So I take these three lines, top plate, plywood nosing, and that little plumb line that meets the plywood at the top there, and I drag them over to the side, and that's how I'm going to create my valley. And so you'll notice that this distance from here to here at the top of the slope is the same, and I know what my overhang is because I measured it earlier in the plan view, right? I got that from measuring from here to here. And so I can just start up at the top where the intersection of the line vertical coming up from the top plate is to this horizontal line over here. And I draw the slope down until I hit the line coming from the nose of the plywood down there. And I connect those two, and now I know where the top of the plywood is. And then I would just offset 5/8 for plywood and then offset 5.5 for my rafter. Now something interesting happens here because the roof is not a typical wall alignment. And so I wanted to show just for fun, since I have this here, that this is the angle. It's 22.3 for this particular roof. And something interesting happens if I did a normal layout. So let's pretend that this is the outside of a normal wall that intersects at 90 degrees, right? And this is a normal 30-inch overhang to fascia, from fascia to outside of wall. But the distance of the valley is different. It's 3'6" and 7/16. So that'd be a more typical valley that I would expect. If I do the same thing, if I transfer all those lines over to here, and I do the little connect the dots thing with that overhang that I have there, the different valley, and I draw this, right, I connect that to that, that's establishing my top plate for a more typical valley, and you'll notice that the angle is different, right? It's 19.5. And so the angle is different, and that's kind of interesting. And another important thing to consider is that if you were to use your speed square, I think we should get this angle, but the speed square isn't going to easily give us that angle. So here's a little zoom in on my speed square. And I'm pulling through the hip and valley section there, right through a 6. And what does that give me? That gives me about 15, 16, 17, 18, 19, about 19.5. So that's what I would get if I was using this as my guide for the angle of the rafter. But as we saw, when you open the spread up wider than 90-degree angles, it changes the valley overhang. And so it changes this angle here. So just for fun, I'm going to check it out in the 3D model, and I'll use the section cut tool. So I open my section cut tool, and it's 22.3 degrees. So it looks like that method worked.